Hi, in my previous video I designed a handle for this EUC Begode T4. The printing company will sponsor the printing materials, so now I'm waiting for the shipment. Between this time I will make a bumper protector for this top rubber piece so that when it falls it won't crack. This costs around $60, so expensive to replace. I will use the scan data that I scanned from my previous video using the blue laser, and then I will create 3D and cover this front part with the 3D print. This front part is challenging for reversing in CAD because it has different plane and curvature. 1, 2, 3, 4. There is 4 different planes building this front geometry, so it's necessary to have a scanner to scan the surface for referencing in CAD. And then I will show you how I reverse this surface in CAD and create a bumper cover. Here's the scanning data that I received from infrared scanner, the Otter. I have around 930,000 points, which is not much in detail. This is the scan from blue laser, give a lot more details. So I use this part for reference in CAD. Before that, I merged these two point clouds together in the Cloud Compare software. So I merged them that you can see that the upper part is much denser and I can clearly see the screw height and detail of the surface. Here inside AutoX Inventor, I import the point clouds that I merged in Cloud Compare, and then I will just crop the front part that I will be using for reverse geometry. There are several ways to model the geometry of this workpiece. Most convenient way is by making multiple faces and convert them into solid, because this geometry has different faces and angle, so it will be more difficult to model this from the solid. Most CAD software today can do some of the surface function. I will start by making 3D lines. See here, this is a 3D lines. I draw 3D lines that closer to the edges of the workpiece. As you can see that I make it a little bit larger at the top so that I can put in double-sided adhesive tape under it, and on the side I put it closer. On the right side and on the left side I put in the same geometry. This rubber pieces is not symmetry. On the right side, see here, is closer than on the left side. Anyway, I will make this a bumper symmetry. Take a closer look at the lines here. See, I can also adjust the angle until it matches the geometry of the object. See here, I can also change to 4. It's easy to change, and see, I put in all the angles necessary. I can change everything. I change it to 102 degrees. See, then it's changed. I can change the length 25 to 30, so I can adjust and change the edges of the bumper. And after that, I use the patch function to create a surface. So I only click on the edges of the 3D line and it will create surface. It could be 4 sides or 3 sides. After I create the faces, then I use a thicken function to create a thickness of this object. So now it's solid, and it can be exported for printing. When you do reverse geometry with the point cloud, it's very easy to investigate the tolerance. See, this side is touching the plane, and on the upper part is not touching the plane. So you can easily see the interference of the object. See, I put more gap on the top. I leave this for adhesive tape, which is about 1 millimeter in thickness, and the surface of the rubber is uneven, it's not flat, so I need to allow more tolerance. And then I make fillet edges to smooth the printing. Here it is, the bumper for Begode T4. So when the UC clash, so it hit the bumper first. So I use this until I get the handlebar. This handlebars should arrive sometime next week, and when it does, I make a review of the metal 3D printing. So I will send this for printing in a PLA because I think it's easier to print. Without the scanner, this would be much more difficult to reverse geometry. Let's try if this will fit onto the EUC. This is a gel tape about 1 inch wide. It's very good for sticking onto the rubber soft surface and the 3D printer part. I think the 3M also have this too. You don't need to put a lot of tape on this because you won't be able to remove it. So this one is about 1 millimeters in thickness. So I just put it in the middle. It sticks very well to the 3D printed part with a not so smooth surface. Okay, let's take a closer look here. See that the gap on this side is a little bit wider than the other side. The gap on this side is narrower because the rubber is deformed, so it's not symmetry. So now if I want to put it out on the floor, I can just lay it like this. This should work. I put the download link in the description. You can print it yourself with the PLA or ABS. Thanks you guys for watching. I'll see you in the next video.